All right, and this one we're trying to figure out how much of the sandbox each brother has. And it's a circular sandbox, and it's 8 feet all the way across. All the way across would indicate diameter, so that's going to be 8. So we need to figure out how much space is in here and how much space is in here. So let's do that. To find the area of a circle, we're going to need the radius. Radius in this case, halfway across, is going to be 4 feet. Okay. Now we can just put in our formula and figure out what the area of the entire sandbox is. Okay, we're still going to have to do something to it at the end, but this will find us what the entire circular sandbox is. So radius to the second power is going to be 4 to the second power times pi, which is 3. 4 times 4 is 16. 16 times 3 is going to be 48. So the sandbox, 48 square feet. So 48 of those squares in the back that say square feet is how much space that sandbox takes up. Now, you got to understand, this is the answer to the area of the sandbox, which is great. But we want to know how much space each brother has. So if we think about this, the sandbox, if each brother would have part of it, would be split in half. So we basically just need to split this in half. 48 cut in half, 48 divided by, cutting something in half is just like dividing by 2. That would give us 24 here and 24 here. You would expect if you added both halves together, you would get the entire circle, and you do. 24 plus 24, or 24 times 2 is 48. So the whole sandbox is 48 square feet. Half of the sandbox for each brother is 24 square feet. This is probably one of the worst looking decagons that you're going to see, but it took me a while to figure out how to even draw this. So first thing you got to know is a decagon has 10 sides, which I've got them labeled on here, and you just kind of have to assume it's a regular decagon. It's what the problem says. So just kind of picture all these sides as being the same. Okay, we do not know how to find the area of a decagon. The question is, which shape is similar enough to this that we could probably use to find the area of a decagon? And the answer to that would be a circle. Okay, this is dang near a circle right now, but I can just kind of fill in the blanks here, and there's not a whole lot of difference between a decagon and a circle, so we could probably use the same formula to find the area. So if I did that, it would just be radius to the second power, so that's the diameter, so I need the radius. The radius is half of that. Half of 11 is 5.5, 5.5. Okay. So now I just need to use our formula, which is radius to the second power times pi. So radius to the second power, 5.5 to the second power, 5 and 5/10, 5.5, times pi. We know pi is 3. And then let me do 5.5 times 5.5, and we get 30 and a fourth, 30.25, 30 and 25 hundredths. Okay. Now we just need to times those together, and I know in my head that would be 90.75. 90 and that's 3/4, 90 and 75 hundredths. Okay. So that would be our answer to the question if this was a circle. Now, if you think about it, and this part's just going to be estimation basically, but the circle is going to take up more space than the decagon would because the circle goes all the way around. The decagon kind of cuts in and then cuts in and cuts in. So we probably should take a little bit off of this. And I don't know, this is just an estimate, but I see maybe if we took off all the empty spaces that we don't need that the circle caused on here, maybe we get down to like, I don't know, and this is just an estimate, maybe we get down to 85 or something like that, okay? But otherwise, the answer to this question, similar enough, is definitely going to be a circle for this. This question wouldn't be real tough if we knew what the base was. They give us a hint, though. They say it's a quarter of the height, okay? A quarter means a fourth. Okay, so we can do this and we can figure this out. Basically, all we're going to need to do is take the 12 and find a quarter of it, which is easy to do. There's 4 quarters in a dollar, so we just need to split this into 4 pieces, okay? Or basically just 12 divided by 4. So that would be 3, 3, 3, and 3. Every quarter is worth 3 because we have 3, 6, 9, 12. So our bottom of this thing is going to be 3. Now, a quarter would just mean 1/4. So we could have also just done 12 divided by 4 pieces and got 3 for our answer. That would work too. But you really do need to probably understand what a quarter means to get this question right. 1/4. Alright, now we can just use our formula to find the area of a triangle. We need base times height first, and then divide by 2. Our base is 3, height is 12. 3 times 12, 3 times 10 is 30. 3 times 2 is 6. 30 and 6 would be 36. Now, since we're dealing with triangles, we got to cut it in half. We got to divide by 2. Divide by 2. 36 divided by 2 is 18. So we get an area of this problem, 18.